Okay, today's lesson 7.6, we're choosing a factoring method. Today is the last lesson of this chapter, so it is still involving factoring with just a wrap up of everything that we've learned so far. Remember, for it to be completely factored, it has to be written as a product and cannot be factored any further. Written as a product, that just means if I ask you to factor 12 and to write that as a product, you're going to multiply the factors together that give you 12. So we could have 1 times 12, 2 times 6, 3 times 4. It's now written as a product. We have factors. You also have to make sure that it cannot be factored any further. So let's try this out on example 1. Are these completely factored? Well, let's check it out on A. If I put parentheses around the first group, I can now easily see that I have a product. I have the first group times the second group. So let's look at this first group. Can I factor anything out of 2x? No, I can't. It would just remain 2x. Can I factor anything out of x squared plus 4? No. Since this is addition, I don't have the difference of a perfect square because this is addition. It's not subtraction. Therefore, I can't factor anything out. So yes, it's already completely factored. And then looking at B. I have a product, but is it completely factored? Can I factor anything out of this first group? 2x plus 6. Yes, I can factor out a 2. So that's going to leave me with x plus 3. And then I can't factor anything out of x plus 5, so it's just going to stay the same. We are now factored completely. Okay, these are just steps building up to a long polynomial. Okay, when you're factoring completely and you have a polynomial, you want to look for the greatest common factor. Okay, so my greatest common factor out of looking at our numbers, I can see is going to be a -2. I can also factor out an x. So that's going to leave me with y squared minus 8y plus 16. Okay? So now that I've factored out this -2x, I need to look at my trinomial. Okay? So, do I have a perfect square trinomial? Well, let's check it out. Is y squared a perfect square? Yes. Is 16 a perfect square? Yes, but let's make sure it's a perfect square trinomial. So your y squared is going to factor to be y times y. Your 16, since I want it to be negative, but when I multiply positive, I want it to be -4, -4. So to check it, to make sure we get -8y, we have to take a factor from each of these and multiply. And then I need to double that. So I get -4y times 2 gives me the -8y. It checks out. So this trinomial is going to factor to be y times y minus 4 minus 4. Don't forget this -2x that you already factored out. Now to simplify this even further, y minus 4 times y minus 4 can be written as y minus 4 squared. We are now factored completely. Moving on to example 3. Okay. I do not have a perfect square trinomial, but if you want to double check to make sure to see if you can factor, remember you're going to have to find your factors of 2x squared, your factors of 4, and your inner plus your outer have to equal 5x. Okay, my factors of 2x squared are going to be x and 2x. My factors of 4 are going to be 1 and 4, or 4 and 1, 2 and 2. Check it, your inner, you're going to have 2x times 1 is 2x, plus your outer, 4 times x is 4x. Add those together, we get 6x, not 5x, so that's not going to work. We will continue checking. 2x times 4 is 8x, plus x gives me 9x. That's not going to work either. And then 2x times 2 gives you 4x plus 2x, which gives me 6x. That does not work. Therefore, this cannot be factored. Looking at B, do I have a greatest common factor that I can pull out? Yes, I have a 3. I can also factor out an n squared. Remember, everything else goes inside parentheses. 3 divided by 3 cancels out. N fourth divided by n squared is n squared. Negative 15 divided by 3 is negative 5. N cubed divided by n squared is n. 12 divided by 3 gives you the plus 4. You already factored out the n squared. Your next step is to make sure this trinomial is factored. Okay? I can see that it's a perfect square trinomial, but if you're not comfortable with that, factor it the way we learned. Your only factors of n squared are n and n. Your factors of 4 are 1 and 4, 2 and 2. If we multiply, we want it to be positive, but when we add, we want it to be negative. So there's your sign. Which of these added together give you the negative 5? It'd be negative 1, negative 4. Don't forget to bring down that 3n squared that you already factored out. We are now factored completely. Looking at C, the greatest common factor that I have is 2x. So factoring that, 4 divided by 2 is 2. X cubed divided by x is x squared. Plus 18 divided by 2 is 9. X squared divided by x leaves you with an x. Plus 20 divided by 2 gives you 10. Can this trinomial right here be factored? We're going to drop down the 2x that we already factored out. Now let's see if this trinomial can be factored. So I have to find my factors of 2x squared, my factors of 10. My inner plus outer has to be 9x. Inner plus outer has to be 9x. So let's check. Factors of 2x squared, I'm going to have x and 2x. Factors of 10, I can have 1 and 10, 10 and 1, 2 and 5, 5 or 2. Now you're just going to check your inner plus outer to see if you get 9x. So inner, 2x plus 10x gives me 12x. That's not going to work. Inner, 2x times 10 is 20x. Plus 1 times x is x. That's 21x. Not going to work. So we're looking for the 9x. 2 times 2x is 4x. Plus 5 times x is 5x. Does that give me 9x? Yes, so here's your correct factors. You're going to have x and 2x. Plus 2 plus 5. We are now factored completely. And then D, this is our last example. It does involve a few more extra steps. But I can see that I can factor out a p. Everything else will go inside parentheses. So I'll have p to the 4th minus 1. Okay. Now I can see that I have the difference of 2 squares. Because p to the 4th times p to the 4th breaks down to be p squared times p squared. Negative 1 breaks down to be 1 minus 1. Positive 1 times negative 1 gives you the negative 1. So I can see that this difference of 2 squares, I'm going to bring down my p that I already factored out. This is going to factor to be p squared times p squared plus 1 minus 1. Okay. Check inside your groups. Make sure nothing else can be factored. Can't factor anything else out of p. I can't factor anything else out of p squared plus 1. Look, here we have the difference of 2 squares as well, because p squared times p squared breaks down to be p times p, and negative 1 becomes 1 times negative 1. So this is going to factor to be p times p plus 1 minus 1. We are now factored completely. And your assignment for this lesson is going to be 20 through 48 evens. 20 through 48 evens. Again, that was 7.6.